Now we're going to move on to confidence statements. We're going to look at another good sample taken by the Gallup poll. This is a Gallup poll on values and beliefs. I've given you the entire article in your guided notes, so if you would like to pause the lecture at this point and read the entire article, it's very short. I would strongly recommend that you do that. I would like to focus on just a couple of sentences from that article. In the article you read that Gallup's annual values and beliefs survey asked 1,535 American adults about the moral acceptability of 20 behaviors, and having an affair was found to be the very worst, with 91% of respondents deeming it morally wrong. 91%, this sample proportion, is called a point estimate of the population proportion. Further, we read, this is under the survey methods, for results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of error is plus or minus 3 percentage points. So a conclusion could be stated as follows. We are 95% confident that 89% to 94% of all American adults feel that having an affair is morally wrong. Now, where did we get this 89%? Well, that's just our sample proportion, 91%, minus the margin of error. This 94% is our sample proportion, 91%, plus the margin of error, 3%. So that's where we're getting our 89 to 94%. Let's try to understand what this 95% confidence means. So going back to the survey, it was stated that for results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is plus or minus 3 percentage points. So if we take many, many samples, like we did with the Reese's Pieces, using the same method that we used to get this one sample of 1,535 adults, 95% of the samples that we take using that same method would give a result, that is a sample statistic, that is within plus or minus 3 percentage points of the truth about the population. We call that the population parameter. What does that look like? Let's take a look at that. I've got another applet here that's going to construct these confidence interval estimates for us. So we're going to construct a 95% confidence interval estimate. We already know that the sample statistic has this bell-shaped sampling distribution. We saw that with the Reese's Pieces experiment that we did. Here is the true population proportion that we're trying to estimate here. I'm going to take one sample. Here is my confidence interval. Here's one margin of error, that's the plus part of it. Here's the minus part for the margin of error. So this whole line right here is my confidence interval estimate. Notice that it does include the true population parameter here. Suppose I take another sample. I get a slightly different sample statistic. I add the margin of error. I subtract the margin of error. Here's my interval estimate. It does contain the true population proportion. Suppose I do that 50 times. Notice that almost all of these interval estimates do contain the true population proportion. But look at this one red one right here. This sample statistic is so high that when I subtract the margin of error from it, it's not long enough to capture that true population parameter right there. You'll notice that 98% of my samples have given me an interval that do contain the true population parameter, and 2% of them have not. Suppose I take another 50, and another 50, and another 50. I can keep doing this repeated sampling. I keep taking more and more samples, and notice what happens. The more samples I take, in the long run, approximately 95% of them are containing the true population parameter that I'm trying to estimate here. So I've taken 1,052 samples, and 96% of the sample statistics have given me a an interval estimate that does indeed contain the true population parameter. That's what we mean by this 95% confidence. It's confidence in the method that we use. So let's take a look at that margin of error. When we're using a sample proportion from a simple random sample of size n to estimate an unknown population proportion, P, the margin of error for the 95% confidence interval is approximately equal to 1 over the square root of n. We call this the shortcut formula, and it's very important that you memorize this formula and know how to use it. So make sure you memorize this, especially by test time. So let's practice. Let's calculate the margin of error for 95% confidence for the sample of 1,535 adults surveyed in the Gallup poll we just discussed for the proportion of all adults who feel that having an affair is morally wrong. Well, the margin of error is going to be 1 divided by 1,535. 1 divided by the square root of 1,535 adults. We're going to find that to the nearest hundredth, that is 0.03, or 3%, just as the article told us. Let's look at another example. Suppose Gallup had contacted 2,540 adults for the survey. We want to calculate the 95% confidence margin of error for that particular sample. Now let's think about this for a minute. 2,450, that's bigger than the 1,535 adult sample that Gallup took originally, and that's the one that had the 3% margin of error. So we're expecting this margin of error to be much smaller. Let's see if that is indeed the case. If I want the margin of error for 95% confidence, I need to take 1 divided by the square root of the sample size. So if I do that on my calculator, I get 0.02, or 2%, which is indeed smaller. So the larger the sample size, the smaller the margin of error. Suppose instead Gallup had contacted only 769 adults for the survey. We want to calculate the margin of error for 95% confidence. Well, 769 is by far the smallest sample of the 3 samples that we've talked about, so we're expecting the margin of error to be much bigger. And sure enough, when we take the margin of error, 1 divided by the square root of 769, we get 0.04, or 4%, to the nearest percentage. Comparing the 3 margins of error for 95% confidence, what pattern do we notice? The larger the sample, the smaller the margin of error is the pattern that's developing. Writing a confidence statement takes a little bit of practice. Gallup's annual values and beliefs survey asked 1,535 American adults about the moral acceptability of 20 behaviors, and having an affair was found to be the very worst, with 91% of respondents deeming it morally wrong. Divorce, on the other hand, was determined by most to be morally acceptable, with 68% of respondents deeming it so. Suppose we wanted to write a confidence statement about the proportion of adults that believe that divorce is morally acceptable. We could say we are 95% confident that 68% of all American adults feel that divorce is morally acceptable, with a margin of error of plus or minus 3%. Or we could say we are 95% confident that 65% to 71% of all American adults feel that divorce is morally acceptable. So we can give the sample statistic, this is p hat, and we can give the margin of error, or we can do the arithmetic ourselves and take the sample statistic minus the margin of error and the sample statistic plus the margin of error and report those values in our sentence. Notice that the confidence interval statements have three parts. We need to disclose the level of confidence. So in each of those statements we said we have 95% confidence, or we are 95% confident. We also stated the margin of error. In the first statement we stated it as plus or minus 3%. In the second statement we applied it and came up with 65 to 71%. We also give the interval estimate of the population parameter. In the first statement we gave the pieces for it, 68% plus or minus 3%. In the second statement we stated it outright as 65% to 71%. Let's take a minute just to do a little checkup on the main concepts of this lesson by answering these questions or determining whether these statements are true or false. In addition, if the statement is false, we're going to make it true, just to deepen our understanding. You'll notice that these are on your guided notes, so you can follow along with me. So, using a random sample to do a survey helps to alleviate bias in the selection of subjects. We would have to say that that is a true statement. So there is nothing to correct there. And we can just mark that as true. I'm trying to get my pen here and it's holding up. Well, just pretend that we put a true in there. A confidence statement is about, here it is. So we can mark that as true. A confidence statement is about a sample statistic. Well, that is false. That's a tricky one. It contains a sample statistic, but it's not about a sample statistic. A confidence statement is about a population parameter. For a simple random sample, the margin of error will be lower if the sample size is larger. We found that to be true. The larger the sample size, the smaller the margin of error. The next statement, every 95% confidence interval will contain the parameter being estimated. Well, that's not what our applet showed. That's false. In fact, about 95% of the 95% confidence intervals will contain the parameter being estimated. And finally, every confidence statement must be made at 95% confidence. Well, based on our examples, that's what you might think, but the answer to that question is false. Every confidence statement does not need to be made at the 95% confidence. At 95% confidence. 95% confidence is what the media uses. So whenever you read about a poll or hear about a poll on the news, the media always uses 95% confidence. But if we were to take a poll on our own, we could have an 80% confidence, we could use 75% confidence, we could use 99% confidence. Confidence statements don't have to be made at 95% confidence, although any confidence statement that you read about in media will be made at 95% confidence.